All right, guys, we're going to get started. If you're not in here yet, you can't hear me, so why am I talking to you? All right. So, your favorite. First of all, how you guys doing? Happy Wednesday. Happy Wednesday. No? All right, so
Here.
all right, let me see. David, okay. All right, so we're going to talk about proofs. No one's excited? I'm hearing everyone cheering. I thought I would say that and I'd hear a bunch of people cheering. No? There you go. There you go. All right, so first of all, before we start the proofs, are there any questions about similarity? Do you guys know the 3 ways to find triangles similar?
SSS, AA, and SAS.
Good. So we have SSS similarity, we have AA similarity, and we have SAS similarity. So those are the 3 we're going to be using to prove triangles similar. Okay. All right. So the first one, I don't know if you guys looked at your notes, but the first one is an example. I did everything for you. Okay. So 4, you do the given first. Then we have the given means they're parallel. So now if we have parallel lines, remember parallel lines mean some type of angles are equal, right? Either corresponding or alternate interior. I don't think we're going to do the supplementary because we want to look for equal angles here because similarity is looking for equal angles. So we look at angle KMN. So if we look here, KMN and angle KJL are congruent because these are parallel and those are corresponding angles. So we say corresponding angles. And then angle MKN here is congruent to angle JKL, which is just the same angle, but for the big triangle. Do you guys notice there's 2 triangles here? We have a small triangle, and then we have the big triangle, right? Sometimes you want to separate them out. And so now we have 2 angles that are congruent. So now the 2 angles of a true triangle are congruent. So we can say triangle JKL is similar to triangle MKN by AA similarity. Okay, I kind of went fast. Before we go on to the second one, are there any questions on what I just did? Did the given. Since I had parallel lines, I found corresponding angles. Then I found 2 angles that are exactly the same, reflexive property. So those are 2 angles. So I got an angle here and an angle here. Now the 2 angles are equal, they're similar because of the AA similarity. Wow, it feels like I'm really in class. I ask a question and it's silent, complete silence.
Woo!
No questions? You all get it?
Yes.
Okay.
I could see how they're similar.
Because AA.
What?
Right, we just found 2 angles that are congruent, and if you can find 2 angles congruent, you're done. You got AA similarity.
Are we turning in the notes? Like for homework?
Huh?
Are we turning in the notes like for homework?
No, this counts for your notes.
Okay.
Yeah, notes, either you come here and watch it, or I'm going to put this on YouTube. So let's say we're going to do this every week from now on. I'm going to do notes like this. And then if you're not here, I'm going to put this video on YouTube, make a comment, and then you got credit for notes. All right, so let's look at number 2. Now, I don't know if you noticed, I gave you the statements for the first, how many? The first 5. Okay. And so all I want you to do is give me the reasons. So let's look at each one. So angle EAB, so let's look, angle EAB and angle DCB are right angles. So I mark it on my, always mark your diagram. Are right angles. What statement tells me that? Why can I say that?
Given.
Given. Yay. Someone answered. Yay. All right. So now we can say those same angles, angle EAB and angle DCB, are 90 degrees. Why can we say that?
Definition of right angles.
Definition of right angle. Wow.
Right angle.
Wow. Someone's getting beat up or something. I hear a bunch of noise. You guys all right? Okay. All right. So now we can say those two angles are equal. Why can we say they're equal?
They're both 90 degrees.
They're both 90 degrees, right?
Yeah.
So we just say substitution. Because we have to have an official reason why they're equal. Okay. And so since we say one angle is equal to 90 degrees and the other angle equals 90 degrees, then we can substitute one angle for the 90 degrees and say they're equal to each other. And so now that we say their measures are equal, the next one, number 4, says that they're congruent. Why can we say that?
Definition of substitution.
Definition of, you're right, but not substitution. When something's equal, we can say they're congruent because definition of congruence. That's what congruence means. Okay, so now we can say angle ABE is congruent to angle CBD. Why? So let's look right here. ABE and CBD. Why can we say those are congruent?
Vertical angles.
Vertical angles. Perfect. And now, what do you notice? We have what? Equal to each other. We have two angles equal to each other, right? So what can we say?
AA.
Triangle.
We can say that
EAB is. Oh no. AA similarity.
very good. Not so bad, right? Yeah, someone's getting beat up out there. What's going on? You guys hear it? I hear it.
Oh.
Wow, what's going on? There's a little kid too screaming.
Yeah, he's playing with whatever he's playing with.
Is he playing with cars or something? Having a blast.
I don't know.
Sounds like it.
All right, before we go to number 3, I haven't seen you guys in a long time. I miss you guys. How you guys doing? Like, are you getting enough sleep? Are you guys going to sleep at a decent time, or do you have no idea what time it is like me?
Really hot.
I miss school.
Right? Did you ever think you'd say that? Did you ever think you would say that?
Ever.
I can't say it because I like being home. I'm in a night owl. So.
Yeah, that's true. I like that. I stay up late too. I'm the same. All right. Hey, who's writing on my paper? All right. You guys can write. You guys can write on my screen. I didn't know you guys could do that. Okay. So someone put given. Good. So that's someone can write the second one. Why is angle XYW congruent to ZYV? Oh, I moved it. Oh, it moves. It doesn't stay there. So why is angle XYW?
Definition of bisector.
Right? Because it's a definition of angle bisector. Bisect an angle, you're going to have two angles.
Big given.
Okay, and so now X, Y over ZY, so XY over ZY is equal to YW over VW. Over VY, I'm sorry, over VY. Why can we say that?
It's given.
It's also given. Very good. So now we have these two angles. I think you're going to have to erase your given, guys. Whoever wrote that, because it doesn't stay. I'm sorry. Thank you for the help, though. Thank you for the help. So now that we see that these two angles are equal, and these two sides are proportional, what can we say? Triangles are similar. And why are they similar? So we have two sides and then the included angle. So what can we say?
SAS.
SAS.
Similarity.
30.
There you go. Good job. You guys haven't lost a step. I haven't seen you in 6-7 weeks. You guys haven't lost a step. Good job. All right. Before I go to the second page, are there any questions on the first page?
No.
No? Good. All right. Now you guys are going to tell me. Number 4. Number 1. What's the reason?
Given.
Given.
Duh. Very good. And angle RPQ is congruent to angle STU. So RPQ, that's right here, is congruent to STU, which is right here.
Alternate interior.
Alternate interior angles. Good. And now the next line, easy. That's just from here. It's from the given, right?
Mm-hmm.
Now, do you understand what it's saying, though?
No.
It's just telling you that UT is 2 PQs. So that means UT is double. So you look at UT right here. It's double PQ. And then ST, which is the big triangle here, is double PR. So basically telling you it's double the size. So it's actually proportional. They're both double. Okay. So UT over PQ equals 2. ST over PR equals 2. Why can we say that?
Is it midpoint?
Well, look at number 3. You guys see that?
Yeah.
Number 3 is an equation. UT equals 2 PQ. What if I divided both sides by PQ? Wouldn't the PQs cancel and you get UT over PQ equals 2? So and then on this side, we would divide both sides by PR.
Would it be a substitution?
And it's not when we're solving equations, and I don't know if you guys remember this property, but it's called the division property of equality, meaning I can divide both sides of an equation and it stays the same.
I don't even remember that.
So division property of equality. And there's 4 of them. There's addition property of equality, subtraction, multiplication, and division property of equality. Just telling you can do it to both sides and it stays equal. And so now if we have both of them equal to 2, I can substitute one of the 2's for the other, or I can do transitive property because they both equal 2 and they equal each other. So you can put substitution here or transitive. Either one will work. So we're just getting number 4 and we're substituting one into the other, or using transitive property to say that those two equal each other. So basically what we're saying is the ratios of the two triangles equal each other. Who's screaming? So we can say now we have two sides that are proportional.
And an angle.
And an angle, so we can say what?
SAS.
SAS. All right. We good on this one?
Mm-hmm.
Yes.
All right. Number 5 is a long one. Uh-oh.
God.
So some of you got confused last week, and I got some questions from this. When you have a triangle inside a triangle, I know you don't have any. Well, maybe some of you guys have any patty paper. It's still on my desk at work, so we can't go there. But if you don't, just what you can do is just separate them. So you have two triangles. You have the small triangle, which is DEC, and then you have the big triangle, which is CAB. So kind of separate them if you don't like to mark stuff up, you know, when they're on top of each other. Just draw two separate ones and then start going through this. So now it looks like 1, 2, and 3 are all given, right? So I'll just write a big given here. You can do that if you want. Okay. So let's mark these up. ACB is 110. ACB.
Supplementary, isn't it?
Why? No, 1, 2, and 3 are given. They're given to us in the given. Oh, you mean if you add them all 3 up, they're all supplementary, right? Is that what you're saying?
I meant number 4 if it was supplementary.
Oh, actually, it's just substitution. You're just adding them together, right? That's just that's just what we call the Triangle Sum Theorem. Remember, that just says every triangle, you add up the angles, they equal 180. Okay. So let's mark up, before we do that though, that was number 4. Before we do that, let's mark this. So ACB is 110, CDE is 40. So this is 40. And the measure of angle B is 30. So B is 30. Okay. And so we know ACB, measure of angle A and measure of angle B is 180 because that's one triangle. We can substitute. We know what ACB is. It's 110, isn't it? And we know angle B is 30, so we substitute it in there. And we get 110, so this is substitution. Right, so all we're doing is getting this and substituting. Getting this and substituting. Okay. And then we substitute, and then we add 110 and 30, we get 140. So we're basically just solving this equation now. Get 110 and 30. Give me 1 second. I'm sorry, guys. Technical difficulties. Okay. So now when we add 110 and 30, we're just simplifying, right? Right? We're just simplifying. And so when I subtract right here, when I subtract 140 from each side, that's the subtraction property of equality. Subtraction. Remember, that just says I can subtract on both sides. And then number 8. Why can we say number 8? Measure of angle A equals the measure of angle CDE. Why can we say
Why
that?
is number 6 simplify?
Because all we did was add up 110 and 30 to get 140. We're just adding on one side. Adding to both sides, so it's not the addition property of equality. We're just adding on one side, we're just simplifying. And so now, measure of angle A is 40. We also see CDE was 40, so we can say they're equal to each other by substitution. We can say angle A is congruent to angle CDE. If they're equal, then they're congruent because that's the definition of congruence. And so ACB is congruent to DCE. Let's look over here. ACB, that's ACB, and DCE, ACE and DCE are the same exact angle.
What is this?
So So when we say two angles are, you say an angle is equal to itself, what do you say?
Hey Siri,
What property is that?
Reflexive.
Reflexive. So now that we have two angles equal to each other, took 10 steps to say that, but with two angles equal to each other, we can say these triangles are similar because of a similarity. All right, any questions on any of these five? All right, so you have 6, 7, 8, and 9. So we have 4 more.
Siri.
I'm not going to go over all of these 4. What I want to do is I want to go over a couple, and then I want you to try them on your own. I'm going to send you the notes with all the answers, and then you can send me any questions. And then someone send me something on Remind asking if we can have like a tutoring session, like a time maybe on Friday. I open up a Zoom, and anyone who wants to come in just comes in and asks questions before the due date. How do you guys feel about that? Like if I have an hour on Friday for you guys to come in and ask questions.
That's good.
Good.
Yeah?
Yeah.
Okay.
Yeah, that's cool.
All right. So let me just go over. Well, let me go over number 6. We'll do that together, and then you try the rest yourself. I'll send you the notes with all the answers. You look at it. You try it. Try the activity. If oh no, we don't have an activity this week. Try the homework, and then if you have any questions on Friday, you can come in on the Zoom. Maybe about the same time, 3 o'clock, and then we'll do it from there. So I don't want to take up too much of your time. I know you guys have homework to do, right? I hope you do. All right, so number 6, LM over PQ. So LM is on the small triangle. PQ is on the big triangle. So that's a ratio. It's the same as the ratio of MN over QR. So I'm color coding this. Is the same as the ratio of LN over PR. So if we have 3 ratios and they're all equal to each other, that means they are proportions, right? So we can say LM over PQ equals MN over QR equals LN over PR. That's given.
You want her phone.
Okay. Then we can say all 3 sides are proportional. Given gives us all 3 sides proportional. So we can say triangle LMN is similar to triangle PQR because of SSS similarity. All 3 sides are proportional. That means all 3 sides ratios are equal. And so now that we know they're similar, we can say angle N is congruent to angle R, because once we know they're similar, we know all of their angles are equal. Remember, similar triangles, all their angles are equal. Okay, so we can just say because of corresponding angles of similar triangles are equal. Because you can also put definition of similar triangles. That'll work too, because the definition of similar triangles are all their sides are proportional and all their angles are equal. So if you just want to put definition of similar triangles, that's fine too. All right, guys. If you don't have any questions, that's pretty much it for now. I will have a session on Friday, but if you have questions, I'll stay here for a while to answer any questions you have about this or anything before or anything else you need. But if you're done, it was good seeing you guys, and I'll see you on Friday, and I'll let you know when we do this again next week. It'll probably be Wednesday at 3 also.
But now my phone is doing her class.
No questions, guys?
No.
All right. Well, if you have no questions, you are allowed to leave. It was good seeing you again. I miss you guys. Take care, and see you soon.
Bye, mister.
Bye.
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 Bye, guys.
Bye.
Open the door.
Bye.
See you.